on Apstra, what we can do, and also some telemetry on top of that. But today, the part 3, we will then continue with Apstra, looking into third-party integration, specifically on NSXT. And once we've done that, we will do another demo showing day 2, things we can do with Apstra, and then finishing up with some DC security to round this up. And if you have any questions, please feel free to insert them into the Q&A, and then me and Mutsu will be able to respond to this. So this is like the agenda for today. So we're going to do the NSXT first, and we'll do a short poll during the break, and then walk through the results before we start this, the second section, which is like day 2 operations of Apstra, and finishing up with data center security and a little poll. So with that said, I'm just reaching out then to Andy. Are you with us?
I certainly am.
Okay, thank you. So then I will hand over to you then, and to give us some input on Nsxt integration.
Okay, awesome. Let me just share my screen. Right, hopefully that's visible.
Yes, it is.
Fantastic. So I think it's probably important as well not to go through the entire architecture of Apstra, but certainly give you, a good understanding of what Apstra is doing. If you were attending one of my previous sessions, and I apologize, this is going to be a little bit of a repeat. If you haven't, then hopefully you'll find it useful. But it certainly leads on to the Nsx integration and what that is, and how we use that data to look for anomalies. So Apstra is it's software which is used to stand up a validated data center. It's built on open standards. We have a single source of truth, and that single source of truth is stored in this graph database, and that graph database is essentially it's a fantastic database for holding highly connected data sets, which is what a network is, right? So a network is physically connected to, one device is physically connected to another, or it's logically connected to another. And these nodes would represent individual elements in that fabric. It might be a physical switch, or a port, or a link, or a BGP peering session. And then the lines between these nodes represent how they relate to each other. Physical switch is related to a port, which is in turn related to a link, which is in turn related to a BGP peering session. So we can store your entire configuration of your fabric within this graph, and we use this graph to look for anomalies in your data center. So once we've built the data center in Apstra and we understand how everything is configured, and what is connected to what, we can then query the fabric to make sure that your actual state, your physical and logical state of your fabric matches your intended state that Apstra has been configured with. So you as a user would drive that user interface either through the UI or through the API, but you drive Apstra, you build your configuration, it'd be placed inside this graph. This graph is then used to drive a configuration. And it's also used to look at analytics, if you like, and to design, build, deploy, and validate a configuration for a data center in the usual way. If you think about how long it takes, the Apstra software can massively shorten that period of time. Actually, this doesn't really reflect on how much time is saved, because I personally can drive the UI and without the API, I can drive the UI and build a 5-stage class with multiple overlays within 30 minutes or so, which sounds like smoke and mirrors, but really it isn't. So we have this high level intent, which is, as a human being, you're describing to the system, I want a network, I want an underlay, here are my pools of addresses that I want to use, I want to add a new rack, I want to add an EVPN VRF, I want to add a virtual network, and you're describing to Apstra the outcome. And that's really what intent-based networking is. It's an abstraction layer. We push that data into the graph, as I mentioned, but also this graph, because we can now say, okay, the vendor that we're supporting here is actually, Juniper with Junos. We know, because we have this single source of truth, we can now derive things like routing tables. And straight out of the box, we can tell you straight away whether the fabric is connected correctly, B2B peering sessions that come up, et cetera, right? There's a whole bunch of analytics that we can do there. And we can also connect to other systems and pull in additional data. And one of them being either vCenter or Nsx Terminology. And we'll do that same graph query. We'll query this graph and we'll determine where those hypervisors are attached, and we can do all sorts of fun stuff to see whether they're attached correctly, and so on and so forth. And I'll go through that in a second of exactly what that means from a data operation perspective. So I won't go through this in too much detail. This is basically saying that, one software, your architects can architect your entire data center, but also that same software through Rollback, you can pass it to the operator now, and they can produce that same validated configuration that the architect would have done. This is describing that we have a multi-vendor approach, Juniper with Evo and Junos, Cisco NXOS, Arista EOS, and Dell EMC Sonic is a match. They come together. VMware, vSphere, NSXT is the integration we're going to be discussing today, but you can drive this whole platform not only through the UI, but with through the API with Ansible or Python. I'm going to flick through these now and go straight to the actual Nsx integration and what that actually means. Maybe I should just. So I will cover off this first of all, actually, because it's quite interesting. So how do we actually sort of model this stuff in Apstra? I say model, we're not really modeling it, we're building it and designing it within Apstra, your data center. And the way that it works is we design this logical device. This logical device, we tell it how many ports, where those ports are connected, the speed of those ports. So we could be designing here or referencing a super spine, a spine, a leaf, or an access switch. But ultimately, we've got to build a configuration for the physical device itself. So we have this single source of truth for the hardware switch. To connect one to the other, we have this interface map. And in fact, it's the same thing for every one of the vendors that we do. So this is an abstraction layer in itself, right? At some point, we're going to say this is a Juniper network running Junos or Evo. And you can say switch by switch, what the NOS is running. And at that point, we're going to derive the configuration for your DC. And as I said, this sort of process can take, 30 minutes, and we'll have a data center up and running, certainly in software. And once we've got this switch that we've defined through this mapping model here that I just mentioned, we create a rack and we create a template. That could be a 3-stage on its own, or the 3-stage could be a pod of a 5-stage clause. And then we build this network within Apstra. We don't need a physical switch actually here. We could pre-stage this whole thing. You could click on one of these switches. We'll have a look in a second. You can click on one of these switches and you can see the configuration that's been derived for you. But yeah, this is the front end. And here, basically, we're in the stage tab. Here is where we can add all of the resources to be able to derive that configuration for your chosen vendor. So the Nsxt integration is an interesting thing for me, because we're hearing a lot of end users deploying NSXT in different ways, and we're going to discuss what those different ways are today. And I think it's quite an interesting discussion to have with your end customer, because a lot of it, because NSXT is essentially sort of one of two things, right? It's going to do an overlay in Geneve, or it's going to be used for micro-segmentation. And depending on the comfort levels of your customer, being able to drive that Nsx interface will depend on whether they're working in silos. So the infrastructure team is different from the networking team. It really depends on what approach they're going to take. Some are super comfortable with it, and others less so. So let's go through and have a quick look at some of the different deployment scenarios. Actually, it's quite interesting because the demo I've got, I'm not describing the demo at all in any one of these scenarios, but I'll point out the difference. So the Nsx integration from an Apstra perspective is all about operational continuity. And what we mean by that is we're not configuring NSX. Okay, we haven't applied that intent-based model to configure NSX. And that question comes up an awful lot. And I guess the reason we haven't done it is because you'd be sort of repeating yourself, right? We'd be doing a lot of development effort that really VMware have already done. You could argue that, NSX is already like, an intent-based model, right? So it doesn't really sort of make sense to do that. But what we do is we look at things like MTU mismatch and VLAN ID mismatch between the hypervisor and the top of rack switch. Again, this is operational continuity, right? So if your teams are working in silos and your infrastructure team are, deploying these services, attaching them to, logical switches, and they're not talking to the networking team, the Apstra integration with vCenter or Nsx Manager will allow the Apstra user to gain visibility of what's happening in that virtual infrastructure. And these are some of the things that we call out, right? So MTU mismatch, VLAN ID mismatch, they are really, really common things, they're sort of, it's configuration which is commonly mismatched between the two environments. And some of these things we've got directly from VMware, right? Degraded lag, hypervisor redundancy check. Again, this is all to do with operational continuity. We also provide the Apstra user, visibility of the VMs by name, MAC, IP address, and also give you some idea of where those hypervisors are actually installed within your data center. We can just say, show me the devices which are hypervisors, and we can say, right, it's this one and this one. So what does it mean to actually, integrate? Well, let's have a think about actually the different ways that NSX can be deployed. So in this environment here, what I'm describing actually is NSXT for microsegmentation only. And if you, I didn't really go through the reference design that Apstra provides, but essentially it's eBGP, a single instance of eBGP for the underlay and for the overlay. So it's multi-protocol BGP, which is essentially eVPN, and VXLAN. So the encapsulation actually happens in the silicon at the top of rack. And we had an engagement with VMware recently, and we asked them a whole bunch of questions, because often for us as Apstra people, because I'm from the core Apstra team, it's very difficult to be able to understand precisely what our customers are doing in the field. And the report we got back recently was this is a very common use case, NSXT for microsegmentation only. Again, it depends on your customer's sort of comfort level as to how they're going to drive the Nsx Terminology. But here's one use case. So for instance here, we extend the VLAN to the top of rack, and those IP packets will be encapsulated within VXLAN, and this will then be a pure eVXLAN solution, right? And it satisfies the virtual workload and the physical workload quite nicely, because these physical workloads, they have no concept of Geneve. So if we're deploying Geneve in the virtual layer, how do we extend a Geneve tunnel to the bare metal servers? Now, I know that VMware do have an agent that you can install on bare metal servers, and I'll discuss that in a second. But they need to be a specific model of bare metal server. And when I say bare metal server, I'm talking about a physical workload here. I'm not talking about the gateway function on a bare metal server. So anyway, VLANs extended to the top of rack, encapsulation in this domain here. So now we've got an environment where actually the guys driving the network have full control of the network and also the overlay. And that might be a perfect use case for your customer. I'm working with an MSP right now, and they don't have a relationship at all with the infrastructure guys, and this model is perfect for them. You know, we also things, and I'll show you what those different things are as we go through this. So Apstra here can then, as I said, build the underlay and build the overlay as you like. So the next model is a pure Geneve model, and we've extended the Geneve tunnel towards the bare metal servers. And actually, in this instance, the bare metal servers could actually be the edge node, right? So this is where T0 is going to sit for exiting in and out of the data center. And I'm working with another customer right now who's doing precisely this. They are a bank in mainland Europe. I can't say where it is because the name will give it away straight away who it is. But they are creating, racks which have their hyper-converged infrastructure in their racks. And they know exactly what's going to go into each slot in that rack. And everything is going to be driven with NSXT for microsegmentation and also the overlay. So they're actually not using VXLAN VPN at all. And in this environment, for their particular use case, they're using Apstra to build the underlay and that stable fabric underneath. And then they're using NSXT to create the overlay. Okay. And this is just another use case. It can get a little bit more complicated. We'll go into that now. So here we now have a customer that has, they have older bare metal servers where I can't install that NSX agent onto it. So I can't extend Geneve to these older bare metal servers. I'm talking, you know, physical workloads now, applications that are running on these bare metal servers. In this instance here, I'm actually describing an extension of layer 2 between the physical and the virtual workloads. So maybe this customer is in a situation where they've decided that they're going to virtualize some parts of an application, but not all of it. So maybe they've got a hefty front end which sits on a bare metal server and they can't virtualize it, or they haven't virtualized it yet, but maybe the database has been virtualized. And it needs, you know, layer 2 connectivity between one and the other. And what I'm describing here actually is a VRF light session between the top of rack switch and the T0 edge node. And you know, if you know NSX, you know that there are multiple other use cases which I haven't really described. And I already called out that the demo is slightly different. And the demo that we've got today, in fact, from the top of rack switch, we've created an EVPN peering towards the edge node because, you know, the later releases of NSX, if you hopefully you knew this, but the later releases of NSX, they supported EVPN as well. They actually support EVPN type 5 routes, and by creating a peering with EVPN, we're exchanging type 5 routes between the virtual infrastructure and essentially the top of rack. Okay, so there's lots of different things that lots of different ways that this stuff can be deployed. The bank that I'm working with, actually, if I go back, what they have here is they have the T0s on these bare metal servers to provide the scale that they need. And actually with Apstra, what we're doing is we're essentially just installing a static route from that top of rack towards those edge nodes. Again, this is, you know, another way of deploying it. So there's some complexity. Some are, if I go back, some installations here where we extend VLANs up and the encapsulation is done on the fabric. Great if the teams are working in silos. It's quite a simple way of sort of consuming NSXT just for microsegmentation only. And this works perfectly, right? We have customers running this today. As I said, I'm working with a bank that's doing this. All they need Apstra for is to create that IP fabric, that IP underlay. It comes with a whole bunch of analytics as well that we can use to validate that underlay. But then they're deploying Geneve over the top. And I've also done many demos to customers where we have this middle ground where we have to extend layer 2 between older bare metal servers and you know, virtual workloads in that virtual domain. So yeah, it can get a little bit messy. And all I've really described here is, you know, that example of how it can get a bit messy. So I've just done that in 20 minutes. Hopefully that wasn't too quick. Are there any questions you'd like to ask before I go into a demo?
I don't see any questions in the Q&A, so I guess you were crystal clear then, Andy, so you can continue with the demo.
Okay, good. Eric, actually, I did notice that you had a break in between me talking about NSXT and the demo, but you're happy for me to continue, right?
Yeah, continue, please. Yeah, I mean, you have the first slide, so please do the demo.
Okay.
Yeah.
Okay, good. One of the things is I'm quite happy to share these slides. There's a whole bunch of stuff in here about architecture. There's a whole bunch of stuff in here about more about the analytics and all the NSXT stuff in here. So if you'd like me to send the slides over to you, then just say so, and we can PDF them up and send them over. At the very end here, I've got a whole bunch of stuff about migration, because largely most of our customers are migrating from something today to an Apstra managed fabric. And the question is, how is that done? And an approach, there are multiple approaches, but an approach is described in these slides of how we can migrate workloads to an Apstra managed fabric. Okay, so let's have a quick look at the front end. So we had a quick look at this on my slides. I think it looks slightly different, but we had a quick look at this as part of that build process. I'm now hunting for the slide. So here, this is the front end of Apstra where we add all the resources. You can see the stage tab, the active tab, and here I've got a demo environment running on this IP address. This is actually built by Jenkins. You've got an entire backend environment where I can just click a button and say, give me a topology. And this is the topology that I've actually asked for. And essentially we have two spines. And in here we have two racks, one with a single leaf and one with a pair of top of rack switches. And in fact, this environment here is a multi-chassis lag, which is slightly different to what we support with Juniper. Juniper, we support ESI, so this peer link wouldn't exist in this example. But anyway, this is an NSX demonstration. So we have actually two compute nodes, NSX Compute 1 and NSX Edge Compute 1. Again, these have all been built by Jenkins. You have to apologize because it gets a little bit hairy sometimes. And this bit here actually is in fact how we represent, we call it sort of a DCI gateway really, because if we're creating a DCI connection between two data centers, and it's very easy for Apstra to create a peering from the underlay and then create an EVPN peering over the top. That's really what this is, an EVPN peering over the top. And what we've done is we've created a peering to the on the edge node. And the way that we would do that is we go to virtual and look at remote EVPN codes, as we can see here. You can see here the T0 gateway is here. We're
Andy, we're losing your voice every now and then. We just check in the connection, okay?
Yeah, it's my poor connection. Can you hear me now?
Yeah, it's dropping in and out a little.
It's my I do apologize.
Yeah, the sound's coming in waves. We're missing portions.
Yeah. Can you give me just 2 seconds? I'm going to quickly fix this.
Mm-hmm.
actually sounds good now.
Yeah.
Yeah.
But as Andy said, so if you want the slides afterwards, we can have a PDF. Otherwise, either you send it directly to Andy or you can send it to me. You have, I will post my email address in the Q&A. So whether you want it afterwards, so please reach out. I know for those of you who attended the last week's session, we are still in processing the documents. So we will send it out shortly, but it might take some more days. So please stay tuned, but they will be sent out. Okay.
Hear me okay now?
Yeah, but yeah, it looks like you're having some problems.
Yeah, I have these strange issues where 5G is more stable than
Wow.
my 200 meg internet connection I've got coming into my good old Virgin Media. Okay, hopefully Virgin Media. Yes.
Oh, it's breaking out. But there's a question actually in the Q&A, and the question is, what kind of version of AOS are you using? Looks a bit different. So, do you know which version you're running?
Oh, hello, Derek. Actually, yeah, the build is slightly different. It's actually not a build that's been released yet. So yeah, I do have the option of using builds that haven't quite been released. So Dirk is a super user, I think, of Apstra. Yeah, anyway, this is all futures, Dirk. You'll see all these coming down the line. Any other questions? No.
No, I think you're fine. Yeah.
My voice is quite stable, is it?
Yeah, sounds good now. Yeah.
Yeah, I'm on 5G now, so let's see how we go. Okay, yeah. So here is the staged environment. As I mentioned here, we can connect to an external system. Here's a virtual infrastructure manager, 10.1.2.55. This is the Nsx manager here. You can see that we're connected, the date that we connected to this system. And if I go to my blueprint, and I look at my active tab, we can query that. We can query that hypervisor, and we can look at the VMs that are attached to that those hypervisors. And here you can see just through this query tab that we have the virtual machine by name, what system it's hosted on, the version of that hypervisor, and then VMs by IP address and also where they're connected to, right? So they're connected to Leaf 1 Ethernet 3. Here's the IP address. And if I go right over, we've got the VLAN IDs. Again, it's a little bit confusing because this has been generated by Jenkins. So they're not giving us some nice, easily consumable names here. MAC address, virtual infrastructure address, which is 10.1.2.55, and the virtual infrastructure type. So if I actually went back to here and said external systems, really the only two systems we have is vCenter and then Nsx Terminology, and this is the one that we've connected to in this demo. Okay, so if I go back to my blueprint, I can go into my active environment here, and the active tab is really the representation of what's running in the data center. Remember, I was talking about this graph database. There are multiple instances of this graph database. We have a graph DB which represents everything that we've everything that's running plus everything that we pre-staged. So if we add a new rack in here, this will get added to the graph database, but it won't be running in your data center, right? So let's see if I can actually do that. Let me just choose the new rack. Oh no, not that one. So if I add this new rack and I go to topology, my new rack will appear here. Here's my new rack that I've just added here. Here's my existing 2 racks, but here's this new one. And I've created those connections within that graph, okay? And if I look at my active environment, that rack doesn't exist. So I've just got this single rack, and I've got this pair of multi-chassis lag switches. And in my staged, I've got this new rack. So here you can see I've made new connections in this graph. I'm pre-staging the addition of a new rack. And so I've got one representation of graph for everything that I'm pre-staging. I've got another representation of graph for everything that's active. And actually, just for completeness, we actually keep a snapshot of every time you push configuration to your data center, we keep a snapshot of that graph DB over time. So actually, I can roll back my entire data center to a previous point in time just by loading up that previous representation of that single source of truth, that graph DB. So here, each one of these are a different graph DB representation of a data center. Unfortunately, there are no descriptions, again, because it's been built by Jenkins. So if I go into staged, I can actually go back into those racks. And let me just delete that one for sake of confusion. And there it's gone, right? And so if I go into the active environment, there's a number of different layers here. Imagine that we're in the active environment. We can see all sorts of different anomalies. So we can see BGP anomalies, cabling, as you can see them here, config, anomalies, hostname, interface anomalies. And right down the bottom here, we can say, okay, which of these servers has a hypervisor, which one of them has actual VMs running on that hypervisor. You're not going to be able to see it too well here, actually, because both of these racks have a hypervisor in it. And you can see that these 2 are green here. If I had a full data center with multiple servers, we'd highlight just the servers that are actually Nsx hosts. So it's not particularly clear here. But you sort of get the point, hopefully. So let's now have a look at the dashboard here. So the Apstra, when we have this data set in graph, we can now use that data set to search for anomalies. There's a whole bunch of anomalies that we can search for straight out of the box. So if you haven't seen Apstra before, we can look at BGP anomalies, cabling anomalies, and imagine you're starting with a new fabric, you push your configuration to that fabric. We're going to tell you straight away whether everything is cabled correctly, BGP has come up, et cetera, et cetera. And this is within the IP fabric. This is towards a generic IP system. So we don't really have things like routers, and we don't have things like servers. What we do is we have a generic IP system, and we connect to it. And we can connect to generic IP systems in lots of different ways. And this is really giving us a view that actually the connection to all of our generic IP systems, whether they're servers, whether they're layer 2 servers, layer 3 servers, whether they're trunks, whether it's a BGP peering session over layer 2 towards an external router, which is also a generic system. We'll give you a view here also as to whether those sessions have come up, right? And we have root verification. There's a whole bunch of other analytics as well. If I quickly go to that tab now. So I was talking about the out of the box analytics, but there's a whole bunch of other analytics that we can use here. We've got a few of them instantiated in this particular blueprint. So device traffic, ECMP imbalance, hypervisor and fabric lag config mismatch, lag imbalance and lag imbalance, VMs without fabric configs, all these different things, right? And if I go to create probe, I can look at all the predefined probes here. And there's a whole bunch of predefined probes to give you a view of how your fabric is running and whether your intended state, your intended design is actually sort of running perfectly in that data center. So imagine that we have all of your connected state in that graph. We can now derive things like the type 3 routes, type 5 routes. We can derive all this up front, and then we can go to the fabric and say, switch by switch, we can say, have you got the right routing table? And if it's not right, we would then raise an anomaly accordingly. And the demo today is really looking at the integration with NSX. As I call it out, we're looking for MTU mismatches, we're looking for VLAN ID mismatches, and a bunch of other stuff as well. The Nsx Manager is here. It's just about to lock me out. So here is our Nsx Manager. It's on 10.1.255. As I pointed out previously, if I go to my active tab and go to my query VMs, here is the IP address of the system that we're connected to. Okay, so this is the right system. And if I go to my end slide, you guys should probably know NSX anyway, but this is essentially what we have, right? So this is a quick overview of that Nsx terminology. So we have these logical switches, and the logical switch is really a representation of a physical switch, but in the virtual world, it's mapped to a VLAN ID, and it represents all that functionality that a physical switch would do, right? Broadcast, multicast, unicast, et cetera, et cetera. And in our environment here, actually, we've got a number of different things. So I've got a couple of logical switches, one on VLAN 160, one on VLAN 150. I tried to set this one up just before the session, but it hasn't come up. So we'll ignore this one on the right. And we've got VMs attached to each one of these. But in this environment, this VLAN 160 and VLAN 150 hasn't been deployed correctly at the top of rack. So we can now look at those anomalies to see how they appear in Apstra. In the dashboard itself, as I said, we've got this out of the box analytics. Underneath, I've created another dashboard actually, and that other dashboard here is to look at the virtual infrastructure health. And straight away, we can see here that we've got a hypervisor. There's a hypervisor VLAN which is missing in the top of rack. It's missing in that fabric. And here you can see that VLAN 160 and VLAN 150 is declared in the hypervisor, but it's not being correctly configured at the top of rack. And now, because Apstra manages that top of rack switch and the configuration in that switch, we can remediate this anomaly straight away. So if I hit remediate anomalies here, it will attach that virtual network to the correct place in that fabric where those ESXi hosts are, just to remediate that anomaly. It's sort of an easy button, right? It's an easy button. If I zoom out slightly, so I won't hit that yet. We'll go back to it in a second. The other thing as well is, what are the critical services affected by that VLAN, misconfiguration? So here we can see that actually, again, the names aren't particularly clear, but we've got the hypervisor, and we've got the virtual machines. And we can see here that these virtual machines are the ones which are missing that connectivity at the top of rack. So in the real world, we'd have lovely names here which describe the services running on those VMs. And we can see straight away that actually this particular service, it's being inhibited because the top of rack configuration hasn't been deployed, and the VLAN 160 and 150 are missing at the top of rack. These are the critical services that are affected. Another anomaly I've done here as well, if I quickly go into this Nsx view here, and I look at system and profiles, I modified the profile here, and I changed the MTU to 1500. Hopefully you can see that. Here's my uplink profile. Again, it's got a horrible name because it is derived by Jenkins. And this MTU mismatch here, it basically pops out in this dashboard. First of all, it says, okay, we've got an inconsistent MTU. But also below here, we can say, it has a low MTU. And this is another probe, which is looking at the data that we're retrieving from the API that we use to connect to the Nsx Manager. We're looking to see whether, that MTU is actually less than or equal to 1599. And as you saw, the actual value is 1500. And you can see that I've set it as 1500 here. And we don't have write access to the Nsx Manager. That's not something that Apstra is doing. All we're showing you here is we have an anomaly, and it needs to be fixed, right? So you're going to need to speak to that infrastructure team to make sure that MTU is set accordingly. And there's a whole bunch of other stuff like, physical NIC lag status. I actually haven't created that anomaly, so there are no anomalies for that one, so on and so forth. Are there any questions with what I've shown you so far?
No, no questions so far.
No questions so far. Okay. Okay, good. So that is really sort of the demonstration of how we integrate with vCenter or NSXT. In fact, the integration with vCenter or NSXT is pretty much exactly the same, right? So if we're looking at things like VLAN's missing at the top of rack, we can get that from vCenter as well as getting it from NSXT. And critical services which are affected by those VLANs missing, MTU mismatches, all those things are exactly the same in vCenter as they are in NSXT. For me, I think this integration really makes sense if you need visibility into where all of those virtual resources are actually running. So if you need this visibility from a networking person who's managing the fabric with Apstra, then that sort of makes sense. But interestingly, if I go back to my slides here, if I call out this one here, so I actually personally think that the integration and the value of the integration could be considered somewhat less if you're creating an IP fabric with Apstra and using only a Geneve overlay, because you're going to have one of two things there, right? That Nsx Geneve overlay is either going to be double encapsulated into VXLAN at the top of rack, which from my perspective doesn't make sense, or Apstra is going to create a pure IP fabric and all of the encapsulation is going to be done at the Geneve tunnel endpoint in the hypervisor itself. So essentially what's going to be happening is if you double encapsulated it with VXLAN, then you're going to have one VLAN for all of your Geneve traffic. So therefore, things like VLAN ID mismatch and MTU mismatch is not really a problem, right? Those issues go away. It really does make sense if you have this type of environment, because you're going to expecting that VLAN match at the top of rack for every VLAN that's extended from your hypervisor to the top of rack. So it really does make sense in this instance. And it does sort of make sense when there's a mix of environments. But anyway, it's really up to you and how where you see that value, I guess. You got a question? What are the requirements to integrate Apstra with Nsx? Can you describe requirements, Hugo? I'm not quite sure what you mean by that. The integration is actually the integration is done, right? So I'm trying to second guess what you mean by that. The actual integration itself is already being done from an Apstra perspective. When you would do it is really when you want visibility. Again, I call it out as operational continuity. So if you're seeing operational challenges between what's happening in your compute teams compared to what's happening in the network, and some of these things are happening on a daily basis, maybe to fix these problems is taking a long time to get visibility, long time to determine where the problem is, then that's when it really makes sense to integrate Apstra with Nsx, because you're bringing both of those teams together through that integration. Whether they like it or not, right? You're bringing those two teams together through that integration. So it's really up to you whether you have the challenge in the first place and you see the value of that integration, the visibility of that virtual infrastructure layer with Apstra. It really depends on where you see that value.
Just to comment, it might be also one requirement is of course on the license side of Apstra. So then you need, in order to do this, you need the premium license. That might be one thing.
Yep. Yeah. So yes, so it is a licensable feature. Absolutely. So some of the stuff that I'm discussing with product right now actually is I think we can do some really good stuff with the integration. And what I want to see actually is in this active tab here, if I click on this Nsx compute node, we have this thing called a headroom. And headroom traditionally was used to choose 2 points in the fabric. So I've got this compute node here. Let me just choose the other compute node, which is that one. No, it's not that one. Is that leaf one? Is it that one? Yeah. So here you can see I've actually got one hypervisor here, which is basically dual home to the 2 top of rack switches. This is the MC lag switches that I was talking about. And you can now see every hop between this host and this host throughout the fabric. Okay, and if I mouse over it, I keep doing it. If you mouse over it, you can see a number of things here. So everything's green, which means you've got the full 10 gig. This is a demo environment. I don't know how many traffic running through it. But you can see every link has full 10 gig. But you can also have a quick snapshot of, you know, what's at a sort of a high level. These are just counters, right? But it's giving you a very high level, how much of that resource is still available, how much of it is being consumed, how much of it is TX, RX, et cetera, okay? Is it multicast, unicast, et cetera? And it gives you a quick view of between 2 points in the fabric. It tells you, okay, these are all my available paths, and this is how much headroom you have. Now imagine, and this doesn't exist today. I'm just talking about some of the stuff we're discussing within product. And now imagine going into my query tab here, and I see these VMs, and I choose 2 VMs. So someone says, oh, my application is running poorly, and I can choose sort of, you know, this VM. I can now choose this VM, and I can say, give me the headroom view between these 2 virtual machines. And actually what pops up is, if I go back to this, what pops up is actually a view like this. But in fact, it's going to show you virtual machine, logical NIC, physical NIC, top of rack, and all the way down to the other virtual machine on the other side is going to go, you know, top of rack is going to go hypervisor, is going to go physical NIC, logical NIC, virtual machine. So if we can gather statistics from you know, the logical NIC and the physical NIC perspective with respect to things like, you know, errors or retransmits, or, you know, how much of that logical interface is being used, we can give you a view from the logical layer all the way through the physical, all the way back down to the logical layer. And I think that would be super interesting moving forward. And some other things that we're also looking at as well, and I'm now talking quite a long way out, if you're listening to me, Dirk, is if we can now take flow data in as well. I can now tell you for a given application type, certainly by port, right? For a given application type, I can now trace the path from a VM all the way through that fabric and tell you exactly what's being utilized link by link for a given application. And I think that integration will be super cool. And I'm talking freely now, right? This stuff doesn't exist today, but I think the integration between the virtual and the physical layer is something which I think is missing in the market. And Apstra has all of the keys, it has all of the data, apart from flow data today, but we're looking at how we can accomplish that as well. But yeah, the more data we can consume within this model, the more visibility that we can provide. So hopefully some really good things are going to be coming in the future. Eric, that's pretty much it for the Nsx demo.
Okay, perfect. I don't see any question, but I do have one question. I mean, you mentioned the use cases, like you had the micro-segmentation, I think you had the mixed one and the pure Geneve. Of those 3, where do you see the most interest from customers today?
Oh, well, that's a difficult question because
yeah.
Actually, for an ease of adoption, so if you have customers using NSXV, I don't know how many are out there. But if you have customers using NSXV, they would have deployed NSXV for policy. And NSXV had no overlay, right? So there was no concept of Geneve with NSXV. So customers who are migrating from V to T are deploying this type of model. And again, it really depends on how much of a skill set and they have in their organization to drive that Geneve interface. And also, this might be old information. Imagine encapsulating every IP packet with the CPU, which is essentially what's happening with Geneve. So if we go to this model here, the encapsulation into Geneve is done via the CPU. So the more networking traffic you have, the more CPU cycles that you're going to use to encapsulate every packet into Geneve. And there always used to be a scaling challenge. Whether there is now, I'm not sure, I'm not up to date with it, but there always used to be a scaling challenge with Geneve because you're going to need a lot of CPU power, right, to do that encapsulation. And you don't have that problem here because the encapsulation is done in hardware in the switch ASIC itself. So the question you asked, Eric, is actually quite a complex one to answer. It depends on the skill set of the end user, whether they're coming from NSXV to NSXT, what sort of scale they need, and yeah, all those things together really as to the approach that they take. But certainly VMware, when we asked them that question, they said this is actually quite common. And I think it's quite common because, getting a customer to adopt Geneve in their departments is not necessarily that straightforward. In the early days, VMware went to a customer and they said, look at this great stuff called Geneve. And the infrastructure guys would say, we know nothing about networking. It's a black box. Why are you talking to us about networking? And they had a major problem in the early days trying to push Geneve into the infrastructure teams. I think they're winning that argument. That's my personal opinion. But like I said, interestingly, the conversation we had literally, I think it was last week or the week before, we have a direct engagement between the Apstra product and VMware product. And we asked the question outright, and they said, actually, this is the most common model today. Was that clear?
Yeah, I mean, thanks, and I appreciate it's not like an easy answer, but it gives you some ideas at least. So I think at least what I've heard, the microsegmentation, what you show here is probably the most demands we get from our customer, which of course is mostly networking guys, so they understand this. Yeah.
Yeah, for me, the elephant in the room is not really the elephant in the room, but the bigger question is, what does microsegmentation actually mean? Because we have lots of end customers come to us and say, what do you know about microsegmentation? And of course, the first question is, what do you mean by microsegmentation? Because microsegmentation was really designed for the virtual layer here. And if a virtual machine is talking to a physical workload, whether it's across layer 2 or layer 3, you could argue that NSXT is going to capture that use case quite nicely from a microsegmentation perspective, right? Because you're going to apply the policy at the VM rather than at the bare metal. But then the question comes in about, okay, well, if I have bare metal to bare metal, how do I then manage microsegmentation then? And there's lots of different ways to do it. And I think sometimes we get caught up in this idea about microsegmentation is the answer. But the question is, what's the question? If that makes sense. So yeah, it's interesting topic actually.
Good. Actually, we got another question which is related to Nutanix. I think you could respond to that one, Andy. Are we thinking about doing that in the future? Or?
Nutanix, yeah. So Nutanix is a tough one for us because it must have been 3 years ago, maybe 4, when I was part of the pure Apstra team before the acquisition. We went to Denmark for a .next, and we spoke extensively with Nutanix about an integration, a direct integration, with Nutanix. Largely because they don't have an overlay, right? They have no answer. They have nothing like Geneve. And we created an integration at that point, and it was essentially using webhooks. And imagine an infrastructure guy creating a new service or publishing a new service, and they attach it to, a virtual network. And we're in that realm of the virtual network doesn't exist at the top of rack or whatever might happen. So the actual integration we created at that point used a webhook to get some visibility of what was happening in Neutron. And it's Neutron, isn't it? I think it's not Neutron now. What's the
Neutron? That's
yeah, that's OpenStack, isn't it?
Yeah, it's OpenStack. Yeah.
What's the I can't even remember the name of it. Anyway, so
No.
we had the integration, and it was all working perfectly. But actually, what we didn't have over, and I'm now saying 3 years, what we didn't have was a customer who actually needed it, because we found that most customers deployed Nutanix in very small environments, like 1 or 2 racks, and it really didn't make sense to have a heavy sort of lift integration when all of our customers really had 1 or 2 racks of Nutanix. And why it didn't make sense to continue with the integration. So we had the integration and then we dropped it. And in fact, over the last 3 or 4 years, I only know one end customer of ours who has a large Nutanix estate, and they've not even requested the integration from us. So yeah, so the answer was a long answer. We used to have it and we dropped it because we didn't have any customers who actually requested it. So the code is sort of sat there and stale. And right now, all I can say is we don't support it. We did, but we don't.
Yeah. Okay. Good. Yeah, I see now we're close to top of the hour. I don't see any more questions. So the idea now was like to run a poll, and then during the poll we take like a 5-minute break. So please fill out the poll. It's only 2 questions. And then after 5 minutes from now, so Sarah, would you mind launching it, or Mucho, the poll?
Yes, I'll launch the poll.
Okay, yeah. So yeah, so there it is. So we only have 2 questions, so please fill it out. And then for now, it take like 5 minutes, and it will stay at least for 5 more minutes, and we can have a short discussion on the poll results after that. Okay, so see you in 5 minutes from now. So we are slowly ending this break, and I still see people are responding to the poll. I think in a few seconds then we will end the poll and then just walk through the results and share it with you. So I think I end the poll now, and then we want to share the results and just have a short conversation and comments on those results. So hopefully now, can you see the result? Please confirm.
Yes.
Okay, good. So the first question then is like, after the presentation done by Andy and showing some background info and Nsx integration. So what is this interesting for your customers? Yes, it is. But it seems like still need to understand more before having a conversation. And I'm not surprised to some extent. So maybe what's your opinion as well? And on this one, I think this is a quite tricky topic, to be honest.
It is a tricky topic, yeah, because there are so many variables in play, right? Just data center security could be one, right? How is that going to be implemented? So yeah, but largely I think it's a lot to do with how it's been deployed, how those two environments have been deployed, and where the customer's pain points are. So if they're seeing challenges because their teams are working in silos, then visibility for that operational continuity may be something they're looking for. So yeah, but it's complicated.
Yes, it is, and that's why we have, from the Juniper side, we have some very good guys that can help out. And I think also in general from Juniper, we need maybe to better articulate the value of this one, but still we are usually network engineers, and this is, as you mentioned, for the infrastructure guys, networking is a bit scary, and the infrastructure for networking guys sometimes a little bit scary. So there's a challenge to overbridge that. At least that's how I see it. So going into the second question then, so have you discussed Nsx integration with Apstra with your customers? And a few of you has, and I guess that relates to the first question. So I think maybe this is sort of normal. We're hoping to have more customers conversations, of course, but this is, I think this is one that, correct me if I'm wrong, Andy, but this is something that we're seeing more and more interest, and maybe that's based on that we also communicate this more externally. I don't know if that's the right interpretation or not.
Yeah, I think, again, it just comes down to pain. And quite frankly, if the customer has no pain, then there's no point, integrating the two platforms together. But largely, most of the customers we speak to have really no idea what's happening in their infrastructure team. Actually, that's not absolutely true. I'm working with the university right now, and they have a small team, and they all do everything. So they're very different. I asked them the question outright, do you work in silos? And they went, nope, we only have one team doing everything. So, but they were also interested in the integration because it allowed them to view the two domains together, rather than as sort of separate infrastructures, as you will. So yeah, and all I can say on this is, if you need some assistance to have that conversation with the customer, then just reach out to us. We can do these demos again. We can have the right conversation with your customer to work out, if there is value in that integration for them.
Great then, but with that, I would say thank you, Andy, for attending and doing the demo. Much appreciated. And with that, then I think we will move into the next topic. So once again, Andy, thanks for attending.
Great. Thank you, guys.
Yeah, thank you. And by that, I will then show you what we're going to do next. The next thing will be Mutu coming up and do some more demo. Hang on. And we do more on Apstra day 2, and then I will finish up with some data center security, which will be quite quick, to be honest. But with that, I will then hand over to Muto. So please, Muto.
Yes, I'm going to share my screen. So are you able to see my screen now?
Yes, we can see it.
Okay. So thank you for joining the second part of this session today, where I will walk you through a little bit of the day 2 operations. And the agenda is to, Andy made a nice framework for me so I can quickly jump into the demo. I don't have to introduce you to day 0 and stuff like that. So in the demo part, what I want to show you today is, following the headroom and traffic heat, we will introduce some anomalies into the fabric and see how you're able to see those anomalies and troubleshoot the fabric better. We'll do a time Voyager rollback, and we'll do a device maintenance mode. So what happens in the background when you take out a device in maintenance mode? We'll create an IBA probe, and if time permits, I'll also show you some of the APIs that we have, and within the tool how you can actually instantiate those APIs as well. Just a quick recap, right? So for Apstra, everything is intent-based, right? So we put our intent as a blueprint, and then as a framework, you derive the configuration from this blueprint and put that configuration on the devices. But you also use the same blueprint and you derive the expectation from the network, right? That's the part more interesting for the operations and monitoring, just to know, is my network behaving as intended? So for us, the blueprint, the graph store on the devices are the constant things, and then from which you derive this automation of monitoring and automation of configuration, or just subsets to different aspects of this automation, right? And when it comes to day 2 operations, we normally have to distinguish between changes, right? Where your network, you're continuously changing. So in day 0 and day 1, you deploy the fabric, but during day 2, you are kind of extending the already deployed fabric. Like you might be adding new links, leads, or racks, or decommissioning some of them. You might be adding new virtual networks. You'll be rolling back and forward, doing device maintenance and OS upgrade. So in all those cases, you're pretty much doing some changes. So the question is, how can Apstra help you to do these changes in a reliable way, right? You need, whenever you're talking about changes, it's always about maintenance windows. You need to know, do these pre-checks, do the change, and do these post-checks. Have you broken something when you do a change, right? That's the most important thing that we want to make sure, right? And we are going to see today how Apstra can help you in that. And then the second part is actually the kind of visibility, like what kind of information can we pull from those boxes and show them as analytics? Because when you have a complex network, there are a lot of data coming out, or potentially you can pull a lot of data from those boxes, but do I need to do all that? And that's where your intent-based analytics and these graph queries, and last week we saw how to pull this graph. We wrote these graph queries, and today I will show you how to write an IBA probe. I'll take an example for that. Okay, and this is pretty much sums up the entire day 2 operations, right? There are a lot of network events happening out there in the network. And because Apstra knows the single source of truth, and it can extract the knowledge, it can really classify what is the intended and unintended operational state. Once you know that, then you can go ahead and then just solve, recommend, or notify the anomalies, right? So let's quickly get on to the demo part, right? I have an Cloud Labs-based demo environment here, as you see here. Eric, can you confirm if you're able to see my screen? Is it okay?
Yes, can see your screen.
Perfect. So here you see the dashboard here, everything looks green, like this one as on day 2 network engine you want to ideally see, but it's never like this, right? You know that. If you click on the active tab, you actually see what kind of network is actually being deployed. So I have a couple of spines and 3 leaves and so on, right? The first thing that probably what you can see is the headroom, like what Andy already introduced to you before, right? So you go to the active tab and click on the leaf 3. On the left side, you see the neighbors, right? So what you essentially see here is actually the intent, right? What you have the layers here. The layer currently is showing the intent. So what is the expected intent? Is there anything that is being violated? Whether my cabling is correct. You know, sometimes when somebody does the cabling, they might connect and leave to a spine onto different ports, and immediately Apstra will tell you, you know, this is not an intended state, right? So if something is violating, you immediately show it as red. And you also see, if you click on the headroom, that's where you see the connectivity between the leaves and spines and all those traffic things that Andy was telling you. And one thing is either you can see the real-time traffic statistics, right? Or you can go to a time series and then go back in time, shift your hours and then see what happened to the fabric across a period of time, right? And as Andy was telling you, in the neighbors, you see this kind of headroom, and then you just have to change this layer from intent to traffic heat. That kind of tells you how much is my network being loaded. When you have a lot of traffic, of course, this is a demo environment. I don't have a lot of traffic. Everything shows green. But over a period of time, you can really see the different traffic patterns, like 60 to 80% will be shown as orange. So it shows you the traffic heat across the links to your spine and lead. This can be really useful as well. So let's go ahead and introduce some anomalies and then see how Apstra is going to show them in the GUI. So I'm going to pull this Apstra Cloud Labs thing. Now this is quite interesting. You know, this Cloud Labs partners can also get access to that if they need. So it's a very easy tool to give a demo where I'm going to introduce a configuration change. And also I'm going to shut down a switch interface on the spine, right? I've done this. And then let's watch the dashboard on Apstra and then see how these anomalies are being seen, right? So Apstra is continuously polling your network, and it's constantly checking for things in the background, right? It's something that you can configure like every minute or once in 2 minutes. It's a global configuration. And soon you'll see we introduced 2 anomalies, and hopefully they are going to be seen here, right? Let's give it a minute or so. In the meantime, by the time, yeah, so I already see the first things going red. So you see, as the issue happens, it shows up initially as a cabling anomaly, right? So you have 2 tabs here, right? The staged environment and the active environment. So the stage environment is what you have for pre-staging, right? And active is actually once you have deployed things, and that's where you see all those anomalies being popped up, right? So what you can do is, let's look at the dashboard first. So here it shows up slowly. It initially showed a cabling anomaly, probably because we shut down a certain link and then certain things were not good. And then it shows up a config anomaly as well. But slowly, you know, as the time progresses, you also see some routing table anomalies and other anomalies popping up as and when the Apstra detects that certain BGP sessions went down, and then you're not able to reach certain next hops, and so on and so forth. So let's go to the active tab, right? So let me go to the blueprint and go to the active tab, and here you see all those anomalies popping up everywhere. So if you want to see a certain anomaly, let's go to spine 2. And then on spine 2, you see a config anomaly here, right? And then it shows up the config anomaly, the intended running config, and the actual running config. And then as you go down this route, let's see, the config anomaly is shown here. So here you see that we have manually added a static route here, right? Through the CLI, right? So which is not the intended state. So we are kind of auditing the network, making sure that these kind of manual operations, because in Apstra, everything is intent-based. You're doing everything through the GUI. If somebody logs into the CLI or runs a script or something that would log into a box and create some configurations, these configuration anomalies, there'll be a delta between the actual config and what Apstra thinks it should be, and it pops up here, right? And this is the first anomaly. And what you can do with a single click, apply the full config. What you're doing is we are telling that don't do that, right? We are reverting back that particular config. So that particular static configuration that we configured will be gone in that case. So this is the config anomaly part, right? So everything is now okay. The actual config is now matching the golden config. So Apstra logged into that particular spine 2 in our case, and then it rolled back that configuration, right? So let's go back to the blueprint and see what other anomalies we have, right? If you look at the dashboard, we still have one config anomaly because we broke one of the link, right? And then you also see that some routing table anomalies are popped up as well. So what essentially has happened is if you go to the spine 1, right? And then let's go to the route here, right? And what you're seeing here are some anomalies that tells you the next hops are actually missing here. Because we broke one link, you normally have to have 2 links between the spine and the leaf. We broke one of those links, and it's telling you that some of these are missing. And let's click directly on the route table anomalies here, right? So here you are seeing that some of these routes here, you see the most important parameters are the expected value and the actual value, right? Some of these route verifications are missing. Some routes are missing to certain destinations, but for some of these destinations, it's partial. It means that we are not broken completely, because when you break a link between a leaf and the spine, when it has 2 BGP next hops, and if you lose just only one path, it's telling you that for a certain destination, it's only partial. It's not completely broken, but it's only partial. So it's something like Apstra is checking your routing table continuously, and it's able to tell you whether reachability to a certain destination is completely broken. For example, like the 10.0.0.0/32 is completely broken in this case, whereas for the destination 172.16, it's only partially broken. That means you can still reach there, but you're probably running short of the capacity, right? So you can see that here, and also go to the active tab and go to the spine layer, and you're seeing all these things, right? This is basically seen also in config anomaly, because we went and shut down an interface, right? So what we have essentially done is the actual config is deviated from the golden config. And here you can see we disabled a link here, right? XE000 link facing the leaf 3 was disabled. So what we can do is we can apply the full config here as well. And we will slowly see that all these anomalies are getting cleared up as well, right? So as you see here on the top, a single link down, right? It shows up as a config anomaly. Your LLDP is broken, your BGP is broken, you lose certain routes. It gives you a good summary of all the issues that happened because of that link, breaking a certain link. And once that link comes up, you can slowly see that, the physical layer, your config anomaly was resolved, then your LLDP is resolved, and slowly your BGP and your routing table, once the BGP converges and the routing entries converge, so everything will turn out to green. Now let's give it a couple of minutes. By the time this is happening, right, I just want to show you, in one of our documentation sites in the Juniper.net, you can actually see the Apstra features and what fabric connectivity models are supported across the different network operating systems. what do we support today with Arista, Nexus, Cumulus, Sonic, and Junos, and the fabric connectivity. How do you manage devices on box and off box across the different NOSes, and the different features? How does it look like in Nexus, Cumulus, Sonic, Juniper, and so on? So this can be pretty useful for you to have a look at it. So I'm just looking at if things are converged here, right, on the dashboard. It takes a while, right? And let's give it a few more minutes. Probably we can see another interesting thing for you. On our documentation side, we also have, like if you are trying to build your own lab, right? There is a section called Building a Virtual Lab, where we document how to build your own EVE-NG-based lab, either on EVE-NG or on VMware Workstation. And if you go through this document, it tells you how to set up your hypervisor, EVE-NG, how to install EVE-NG, how to add your Apstra VMs here, how to actually connect it to your management network, and so on and so forth. And then how to bring in other switches, like how to add an Arista device, how to add an Nexus device, and so on. So this documentation can also be really helpful for you if you're setting up your own lab environment. Okay, as I was doing that, we see that all these routing table anomalies, everything has cleared, and it shows a couple of VGP anomalies, but that would go as well as we proceed further. All right. So the next demo that I want to show you is what we call as a time Voyager rollback, right? So what you might be knowing in Juniper, we have this concept of rollback, where we store the last, in case of Juniper, we have the last 50 software version, configuration versions, but in time Voyager, it's seen as more a network-wide rollback. That means like if you're changing the configuration on several leaves or several spines, what you can do is you can roll back at a network level. So you can roll back the configuration simultaneously on several boxes at the same time, right? So what I have done is I've created a configlet called NTP, right? It's just setting an NTP, so a single line of configuration. And what we can do now is we can go ahead and push this configuration onto, let's say, all the spines. So whenever we are changing any configurations, we always come to the staged tab, right? And then go to configlets, right? And let's import a configlet. Let's choose the NTP configuration, here. And then let's put that configuration on all the spines here, right? So this is the template, right? Import configlet, right? So once I import the configlet, it's going to show up as some uncommitted changes, right? So because you are applying the piece of configuration, right? And then let's go and commit this. So adding NTP spines, let's do a commit. What we have done is we have pushed that NTP configuration onto all the spines. So hopefully, let's log into one of the spines and make sure that that particular configuration is already pushed there, right? So I'm going to connect to one of the spines. If you're in Cloud Labs, right, you have a nice interface to connect to. You can just link it to your secure CRT, and you can connect to, let's say, the spine here, right? Show configuration system. You see that the NTP server configuration that we added is pushed to the spine. So what we will do next is we will use the time Voyager rollback feature, right? And then we will go back to a previous state, jump to the previous version, right? So if I do a rollback here, right? every time you do a rollback, you also need to do a commit, right? Do a commit, and then we are doing a rollback and commit. So when you do this commit, what Apstra is doing in the background is it's logging into those two spines in which you are having those NTP configuration you can see here, right? So this becomes our latest current configuration. And if you log into the switch and show configuration, you know, that NTP configuration that we had before this Cont, right? So it can be pretty useful whenever you're doing a big change and something blows up, you want to go back to a working version of the configuration. Okay. Another interesting feature that Apstra has is bringing devices to putting it in a maintenance mode, right? So what is a maintenance mode? So you have an leaf spine fabric like this. Let's say you want to put spine 1 in the maintenance mode. You want to change the hardware or line card, or basically you want to drain traffic away from this box, right? So what with Apstra, what you can do is, because it's an EVPN based, because both underlay and overlay is BGP based, you can apply certain policies on the spine. The spine will basically stop advertising all its prefixes, so that the leaf and all the surrounding boxes surrounding it will not send any more traffic to the spine 1, so that you are gracefully removing traffic from the spine 1, right? So first you remove the traffic, and then you make sure that the spine 1 is completely drained off, right? And then you do your maintenance, and then you put that, once everything works well, you do, maybe you're doing a software upgrade on spine 1, whatever, and then you can put traffic back in. So how do you do that? So go to the stage tab, right? Click on spine 1. On the right side, you see that the spine is in the deploy mode, right? So what you do is you put it in the drain mode, right? And once you put in the drain mode, if you look on the configuration, if you look at the incremental configuration, what happens in the background is, you're basically pushing this policy, the import and export drain policy, right? So you're looking at the protocols BGP, and you see the L3 clause. This is your underlay, right? How do I know it's an underlay? Because the address family is it's family INET, right? And you see that I'm putting an import policy drain, an export policy drain onto my neighbors, right? In this case, the neighbors are the leaves, right? And then also on the L3 clause EVPN, this is the address family is EVPN, right? And you can see the family EVPN, and here we are applying the same import and export policy, right? So the drain policy itself, you can see here, you do a route filter. You match a prefix list, which pretty much matches all your routes up to /32, right? And then you are basically rejecting those prefixes. So this is the policy that will be pushed to all to that particular spine in which you are doing that maintenance, right? So that's what happens in the background. So this is basically a configuration change. So it shows up as an uncommitted change. You go ahead and do the commit where you're draining the spine 1, right? So once you do the drain, first what you have done is you have just pushed the configuration. It doesn't mean that all the traffic has drained, right? So if you go to the analytics tab, what we do is we have some predefined probes that comes with Apstra, and one of this probe is called drain validation. So what is the purpose of this probe? By default, it is set to off, but you can switch it on when you are draining traffic. So this drain validation probe, what it basically does is it really makes sure that your traffic has been drained completely, right? The first step is we push the BGP config to all the spine, to the spine you want to drain. And then if you enable this probe, you are actually checking the traffic on that spine, because whenever we are having a large data center, whenever we are changing something at the BGP level, it takes some time for traffic to converge, right? It's not only this platform, but the other leaves will also converge. Then their forwarding tables will change, and it takes a little bit of time for the traffic to completely drain off, right? So you create a probe by default. That probe is already there for you. You don't have to write the new one. By enabling this probe, you are making sure that the traffic is completely drained before you do the maintenance. Because if you're in an intermediate stage where you change the config, but it can be that there are still some traffic going on in the network, right? So you make sure by doing this. So that's pretty interesting, right? So it's by default switched off, but you can switch it on. And once you are done with your configuration change, you can go ahead to the stage environment and spine one. From the drain, you can put it back to the deploy mode. When you put it back to the deploy mode, again, if you click on incremental configuration, you'll see that you're changing the policy, right? Your export policy, you see here, it's the actual policy that applies to the spine to the leaf. You're basically reapplying the export policy there, right? This is the configuration change. You have to go ahead and commit this change so that you're redeploying back to the normal workflow, right? So this is the device maintenance mode. And I introduced you to the graph theory last week, where we saw the concept of IBA probes, what we are doing with these probes, right? In analytics, you can create these probes. And Andy also touched up certain probes, right? So you can create some probes. For example, I'll show you an example where I will create a predefined probe that we can monitor the EVP and VXLAN type 3 routes. So EVP and VXLAN type 3 is this bum traffic where you're building your remote VXLAN VTEP trees in case you have an broadcast, unknown unicast or multicast traffic. You need to know per ESI where to flood the traffic to. And you want to make sure that certain prefixes, you configure the collection period and so on, right? And you can monitor certain VNIs here. So in my case, I have a VNI called 30,001. So I can monitor this VNI, right? And you can see here, this 30,001 is this available on all the leaves. So this 30,001 is then, if you go to the stage, the virtual, so these are the VNIs, and you can see the 30,001 VXLAN, it corresponds to a certain tenant, and it's there in several leaves, right? And that's what you see here in the probe here, right? In analytics probes, if you go to VXLAN type 3, these are the different stages. These are the processors, right? They're taking the output of one processor and feeding it to another. We discussed about the probe architecture last week, right? Where you filter something and then you process it. You see that whether it's sustained, and only if it is sustained for a certain period of time, you report the anomaly and so on. So now what we can do is we can go ahead, log into a certain leaf and, kind of remove, let me log into one of the leaf. Leaf one probably, and let's show protocols, EVPN, and you see 30,001. Let's remove this. Doing a config change, but this can also be possible, during a network change, you might be losing connectivity to certain VNIs, right? So I'm just killing the VNI 30,001, right? And because we are monitoring exactly this VNI using a probe, you'll be quickly seeing that, that 30,001, because this is a really a specific probe targeting a specific VNI that you want to monitor. You see, it exactly tells you what is missing, and it's exactly missing on leaf one, right? it's not missing on leaf 2, it's not missing on leaf 3. So these kind of probes can be really interesting. For example, you might have a load balancer, which might be advertising some bits. You can monitor those prefixes as well. And this IBA probe concept is really powerful in this sense. I'm just looking into the time frame now. We have some security topic as well. So I hope this demo of the short demo was really helpful. During one of our next sessions, we will also show you some automation stuff as well, like REST API and so on. With this, I will hand it over to Eric if there are no further questions.
Okay, thank you, Mutu. No, I don't see any further questions. But before we go into the next session, so let's launch the last poll then. So I'm launching it now, and so please take some time to fill it out before I actually do finish this session up with some security, which is relevant definitely for the data center. So and the questions here is about automation day 2 operations. So we'll give you a minute or two, and then we just can have a brief discussions on this one, right?
Yeah.
And just a reminder, I saw that at least one of you sent a request for having the slides. If you want, I posted my email address. So if you need them, please just send them over to me. And I will distribute those further on, okay? Great. Yeah, we appreciate this is a long session, so if you don't have the energy to fill it out, but it would be appreciated. It gives both you and your colleagues a good understanding what's happening within the data center community. So please take your time. And I think Mutu, you did all your demo stuff, right? So now
right,
we are getting,
I'm done with it. Yeah. Mm-hmm.
Yeah, okay, great. So now we are give it a minute or two, because given as you said, it's like 20 minutes to the hour. So I do a quick security before we end up this session. So shall we finish it and move on, Mutu? What's your feeling?
Yeah, sure. Well, yeah, I think we have a good coverage.
Yeah, I think so too. So when the poll, and then we share the results. So hopefully now
we're able to see that. Yeah. So the first question was, what was the most difficult thing to automate in a DC environment? So many of you have told, all the above, anomaly detection and remediation, software upgrade, pre and post change checks. So this is also pretty much what we see. What we see is many people have a good solution for configuration generation and deployment. They use Ansible, SaltStack, and things like that. But most difficult thing to automate is actually the anomaly detection and remediation, this auto remediation, which is pretty difficult. And as you saw in one of the demos that we are showing here, how Apstra does it quite efficiently. And also software upgrades. That pretty much one of the reasons why people go for a solution like Apstra, especially for anomaly detection and remediation, which involves a lot of effort to develop your own script if you would do that way. And why is it difficult to automate? That's another question. It's interesting, whether it's because of the complex network design, whether it's because of multi-vendor, lack of management support and things like that. Many of you have also said it's all of the above. So that pretty much sums up the discussion: do it yourself versus buying a commercial solution. I hand it over to you, Eric. It's yours now.
Yeah, I will. So that was the last piece of Apstra for today. So I will stop sharing now, and I will start doing my screen instead. So hang on, I will share my screen. Yes. I'll do this, and now I should be able to see my screen, right?
Yes.
Yes.
Okay, good. we just have like a little bit more than 50 minutes left. So what I would do is to give you briefly overview what's data center and security specifically. And so why is this important? And for those of you that might have attended, like I think it was like 2 weeks ago, we had a session around zero trust data center and cloud. So this is something now we are pushing out from Juniper. But for those of you who have been around for some time, you realize that you see in this slide is similar to what we had before. The key message here is, as you can see, we do have all the products in order to actually build like security all the way from public cloud into your private cloud, and also within your within your data center, which is called intra DC in this slide. So today I will focus on which is on the left side of this slide, which is like numbered here as 1 and 2, which is like within your private data center, specifically what you do north and south when it comes to security, and of course within intra data center, most of that is like east-west security. But first, as you know, oh, sorry about that. So, I mean, the whole portfolio is quite wide. So what I would like you to just take from this session is just like 2 things. First of all, to understand when I walk through specifically SRX 4000, 4600 and above is very good when it comes to performance, even if you turn on security service. We'll look into that. That is not always well known, but it's good to know. Also, the VSRX, CSRX, good to know. I think you know about that, but how do you apply them in a data center? Maybe not well known. And then on the very top, you can see on the right top, you have something called K2. That is actually, we have OEMs now, which I will also cover quickly, which we now call it somewhere here in the slide. It's like Juniper Workload Protection, which is actually, yeah, what it says the name, protecting your applications. But just quickly walking through the VSRX and the CSRX. As you know, these are the virtual platforms we have for either, mostly being used, I would say, for east-west traffic, ensuring that within a data, but it could also be used actually for north-south if you want. And it supports, as you understand, all the major hypervisors, and it's also for the CSRX, the Docker-based. And what is important to know, and I think you already know that, we could, of course, launch it in the public cloud. There you can find it, for instance, in Marketplace on Amazon, so you can buy it directly from there, or you can bring it on with your all licenses and spin it up in the public cloud, such as Amazon or Microsoft or Google Cloud. But this time we focus more on the private cloud and what we can do, and what is specifically when it comes to the VSRX, there are some things which are good to know. And one thing is like when it comes to performance, I haven't seen the latest figures, but historically we have been claiming that we might be the most powerful virtual firewall in the industry. Even if that is not the case, you can see here from the slide that we can then we can do pretty good by using a virtual LAN, doing almost like 30 gig IMEX using a firewall service, and that is quite powerful. Of course, in order to do this requires specifically maybe some things on-prem. I will not go through that, but that is more server related or NIC related, like DPDK or SRIOV, which then enables you to accelerate the traffic going out from your virtual SRX in this case. So high performance is one thing, but it's also important, as you know, when it comes to technology, but also maybe from a commercial point of view when it comes to scale up. So if you compare to an appliance like an SRX 4100, for instance, that you buy in hardware and use the increment, you can upgrade it to 4200, then you get like twice the speed and so forth. But with the virtual SRX, of course, there are multiple ways and more granularly, you can upgrade that one into a more powerful VSRX eventually by adding more CPUs. So that is, some customers are actually starting out with a very small VSRX and then just adding more resources into it, and then once they get more traffic, adds more resources in the VSRX, and they have a more powerful firewall. And of course, scale out. So I mean, we don't talk very much about the public cloud today, but there could be the same thing for if you have a load balancer, for instance. So in order to scale out, we do support that in AWS, for instance, where we have the elastic load balancer integration that we've done, which means that the VSRX then will be sort of handled by the AWS. And if you have multiple VSRX, then that will be load balancing using AWS services. And we have similar things for Azure as well. I think this is well known, but what is also good to know, the CSRX, as you know, this has been around for at least, I think it's more 5 or 6, I think it's even more. And we were maybe a little bit too early to the market, but this is getting more and more attention now when you have some projects. And the reason for that is, of course, this is addressing even more granular than compared to the VSRX. So this is why we do even on a container level, because this one is packaged in a Docker image. So it's very much into the Kubernetes environment, which means we can then do it even more generally. And of course, by doing that, we need a very lightweight product when it comes to resources it uses, when it comes to memory and also disk. Well, we'll come to that later on. But this one, as you know, the only difference is like this one is only doing layer 4, layer 7 services. So it has it's like a bump in the road, which means traffic goes into one of the virtual interfaces and out another one. So we can't do routing or MPLS or anything like that. But that's good, fine, because usually this is only protecting a specific application, or in this case, a specific container. So then we can apply layer 4 up to layer 7 services to protect that specific one, most likely on east-west within a data center. And as you know, the resources needed for each and every type of virtual firewall is quite different. So in this case, for instance, for the CSRX, we don't have any static reservation of the virtual CPU, which is quite good then. And also when it comes to memory used, as well as the image size, is far, far less to compare to VSRX. So, and that comes down then to economics or more on the commercial side. So the CSRX uses less, meaning less money to be run in the data center. Of course, it has not the same throughput as a VSRX, but that is typically not a problem because this is far more distributed, meaning the amount of traffic going through CSRX is usually expected to be far less compared to a VSRX. And of course, the boot up time, which is quite important, you can spin this up like in less than a second, which is very important then, typically if you have a dynamic environment where you need to spin up and tear down security servers across your data center. And across the data center, if you remember, Andy talked about microsegmentation. And this is, as you know, has been a hot topic for many years. And the reason is like, or the question should be, do I need it? And as Andy indicated, the questions could be like, what is the requirements really? Because it could differ. And do you always need this kind of microsegmentation? Well, it depends. And how does that depend? Well, if you have a very flat, for instance, data center, like maybe only one layer 3, where everything is connected and everybody can talk to each other, then it really makes sense to do microsegmentation, meaning that you add some more security according to this slide. But if you have, like in this slide, then when you have multiple VLANs and you do have some segmentation within your data center, and in this case, you're also going through the central firewall, that could be the north-south firewall, then maybe you don't have to do this. So there's no like clear answer when I should use it or not. It very much depends on your usage, but also on your design in your data center. And I think maybe given the time, I will skip this. This is yes, an introduction to microservice and VMs when you need it. But I think more important is like, I will do this last thing, 2 things, which is like one of the things I said you should remember. And that is like, what kind of security service should you turn on for a data center? And as you know, historically, we have been, or we, Juniper, and maybe we have not been very good at communicating that if you turn on services, that will affect the performance for sure. And this slide shows like a typical like attack vector, how a typical attack will go on, going from maybe first exploiting, I mean, your north-south protection, maybe an SRX or MX, or could even be a version 1. And then eventually going further down the stack, then it will start, if you have penetrated that defense and going and already being on a server, for instance, then you will start try to move laterally, meaning east-west, and then you can spread within the data center. So how could you prevent this? Well, the first thing that we recommend, especially for the data centers, is turning on IDP or IPS. And you know, historically, that has affected the performance quite a lot. And maybe not all of you has known that, but as of 21.3 Unix version, that is now fixed. We have another way of performing the traffic flows within an SRX 4600 and above. So that has improved the performance dramatically. And of course, within IDP, sorry, or IPS, there are some things you have to look into why you should turn it on. Well, that is typically, we have maybe not been from Juniper side very good at articulating how you should do this, but nowadays there are some like recommended IPS signatures you can use and try out. And as you know, we are using our own signatures. We are writing that within Juniper, but we also could bring in third parties. So in the end, you have a lot of signatures then you could put into your firewall that will dramatically improve the security within a data center. But of course, once again, historically, this has impacted performance. And what has happened then is like, I skipped this one due to timing, is that this is a pretty old one. For those of you who have been around, this is from 2019 NSS Labs. NSS Labs is unfortunately not around anymore. They went bankrupt. But it shows here, and that could be actually shown today if we did a similar test, that we are very good at actually when it comes to security. And as you can see here now, the figure speaks for itself, but more importantly, in this report, shows that we are in pair or even better sometimes to the main competitors, which I would say is like Fortinet and even Palo Alto. And what it means in the end, a good comparison, which is often used by customers to understand what is the cost per protected gigabits per second, for instance. And then we are sometimes even better with than Fortinet and Palo, but that is only for some platforms. And that platform in this case was the 5K, but I want to show you this one is reflecting the 4600. Because what has happened now since 21.3 as of last year is something we have called Express Path Plus. And what is that on a high level? Well, you know, historically, as it says here on the right side, if you turn on like security service like IPS, antivirus and so forth, the performance dropped to like a couple of gigabits. And that is a little bit, is not according to what the competition does. And for instance, last year we had a project with telco cloud provider in the Nordics, by the way. And what we did then, we enabled the Express Plus on the 4600. And by doing that, as you can see here in the slide, we offloaded some of the traffic from the CPUs and actually going directly into the Trio chipset. And by doing that, then we went from a couple of gigabits up to 42 gigabits per second with all services turned on. And by doing that, this was in a POC, for instance, we beat Fortinet, which had a similar platform. And in the end, then the customer, of course, was really impressed. And the main reason behind this is like two things. First of all, it's a Trio chipset, which occurs in the 4600 and upwards. And also using the Express Path Plus, which is enabled by default as of now, but came out like, yeah, a little bit more than 6 months ago. Last but not least, I will do just a very quick on the cloud workload protection. Now, this is like, once again, the OEM of K2. So you can find some information if you Google on juniper.net. But what we add with this one is like, as it says here in the slide, application protection and application vulnerability detection. So this is like for someone who doing mostly DevSecOps. So I would say this is typically not for all customers. This is all for those who are actually owning the application and know how to integrate the K2 / the Juniper Cloud Workload Protection solution into the application. Because if you do that, then you can add some very nice things. So on a nutshell, what happens then with the workload is like, if you have this integrated with your application, and the application together with the workload protection will then understand if there's something strange behavior going on, someone is trying to attack or doing some strange anomalies with your application, that will be detected by the workload protections, and they can then directly go and talk to the VSRX or whatever you have in your cloud, and then shut down ports or whatever. In that case, you protect your network, most likely then in your east-west things within your data center. But as I said, for this one, this also requires that you have a very close way of integrating directly into the application. But if you do have, this is a very good things to protect your workloads. Sorry about that. That took a long time. We just 1 minute to the hour. So I don't know if there are any questions out there. I cannot see any questions. Do you see that, Mutu?
No, there are no questions as
there.
of now.
Okay. Okay. So with that, then I will just say thank you for attending, and especially for those of you who had taken your time to attend all 3 sessions of this bootcamp. These will be recorded, so if you want, you can look into them afterwards. So with that said, I will hand over to you then, Sarah.
Okay, great. Thanks. Thank you, Eric, and thanks, Mutu and Andy as well. And thank you, everyone, for taking your time to attend today. So this brings our webinar and our series to a close, and you may now disconnect. Thank you very much.